Everyone, welcome back. This is Engineer Hussein Mwasapi. So in this video, we'll basically be revising on proving irrational numbers. Yeah, like that. So before we begin, do not forget to like and subscribe to the channel. All right, so I have a series of questions we're going to be doing. Yeah, so I hope you're up to speed. So the first question says, prove that minus root 3 is not a rational number. To start with, be mindful that a rational number is basically a number that can be expressed in the form of a over b, of which a and b have literally no common factors. Then an irrational number is a number that cannot be expressed in the form of a over b. So whenever you're proving that a given value is not a rational number, or to say is an irrational number, the method that we use is called the method of contradiction. So as you are solving, you can always write method of contradiction. So now, when it comes to the method of contradiction, it literally involves you contradicting with a statement that you give. So in this case, I'm trying to prove that something is irrational. So I have to assume the opposite. So I will assume that whatever I'm having, which is minus root 3, is rational. Because I want to prove that it's not rational, so by contradiction, I assume that it's what? Rational. So if minus root 3 is rational, it means that minus root 3 can be written in the form of a over what? B. Now, since I'm having the minus, all I have to do is to eliminate it. So what I can do is to multiply throughout by the negative, or rather just follow the simple steps where I just introduce now the squares to both sides of the what? Equation. So by doing so, it means that I'll have minus root 3 in parentheses squared is equal to a over b squared. So whenever anything is raised to an even number such as 2 or could be 4, 6 or 8, you always get a positive answer. But in this case, the negative will change to positive and the root will be terminated, and I end up having 3 being equal to the 2 here will be distributed to a as well as b, and I'll be having a squared over b squared. Now basically I can create one straight equation where I can just cross multiply this and have 3b squared being equal to a squared. Now in mathematics, be mindful that if you have something like 4b is equal to z, it simply just means that 4 is a factor of z. If I have 2c is equal to, let's say, 11, a number, it means that 2 is a factor of 11. Or even if I have something like 3b is equal to a, it means that 3 is a factor of a. In a similar manner, if I am having something like 4b squared is equal to, let's say, c squared, it means that 4 is a factor of c squared together with c. Or even if I have like 2x squared being equal to like z squared, it means that 2 is a factor of z squared as well as z. So I hope that's clear enough. So therefore, by having this, I can give a statement to say that 3 is a factor of literally a squared and a. And for that reason, it means that a can be written in the form of the factor times k. Now the factor of a is basically found to be 3, so it will be written in the form of 3k. Now that I have the value of a, I can go back to this equation I found here and plug back for a. Now I'm having 3b squared being equal to a squared. So for every a, I put 3k. So I'm having 3b squared being equal to, wherever there is a, I put 3k, and this will be squared. Now I can distribute the 3, and I'll have 3b squared being equal to 3 to the power 3. Sorry, 3 to the power 2, that's 9. K to the power 2, that's k squared. Now, as you can see, we're having this. Now this can be written in a proper way. We can simplify it by dividing throughout by 3. By doing so, we later on have b squared being equal to 3k squared. So now, what does this tell you again? What does this tell you? Now, in a similar manner as this told us that 3 is a factor of a, even in this case here, we can clearly understand that 3 is a factor of b squared and b. Therefore, I can say 3 is a factor of b squared and b. Now, remember, in the first place, I said that a rational number is a number that can be expressed in the form of what? This guy is simply a number that can be expressed in the form of a over what? B, of which a and b should not have what? A common factor. So now, since I assumed that minus root 3 is rational, it means that minus root 3 should not have a factor that is common. But in this case, 3 is a common factor of a. Again, 3 is a common factor of b. So it means that minus root 3 has common factors which contradict with the assumption that it's rational, which in turn tells us to say that minus root 3 is what? Irrational. So I can give a statement at the bottom where I was saying that since 3 is a factor of b and a, then this means that by the method of contradiction, minus root 3 is not a rational number. So that is literally how you go about solving this type of a question. So we'll move on to question number 2. It says that given that root 10 is irrational number, prove that root 2 plus root 5 is also irrational. Now let's hold the thought that root 10 is an irrational number. So we know that by data that root 10 is an irrational number. Don't forget that. It's an irrational number. So now we know that if we're trying to prove something, in this case we've been told to prove that root 2 plus root 5 is also irrational. So we say method of contradiction. So whatever we're trying to prove is what we assume to be the opposite. So we assume that root 2 plus root 5 is what? Because we're trying to prove if it's irrational. So we assume the opposite, which is rational. So we assume that root 2 plus root 5 is what? Rational. And if it is, it means that root 2 plus root 5 is equal to a over what? B. Because it means it can be written in the form of a over b. Now we need to reach a point where a and b should have no common factor for it to hold true that it's rational. So now if we're saying that root 2 plus root 5 is rational and it's in the form of a over b, remember, mathematically speaking, if I have 2 being equal to 2, it means that what I'm holding is true. If I have tomatoes being equal to tomatoes, then I've proved my equation to be true. But if I have tomatoes being equal to guavas, that wouldn't make sense, because now that's just crazy. How can tomatoes equal to guavas? You get the idea? So what I'm trying to say is that whenever you say that something is equal to, let's say, a over b, where you assume that it's rational, it means that whatever I'm having on this side is equivalent to what I have on that side. But if at all I reach a point where that doesn't hold true, it means that whatever I actually assumed does not hold true. So now what I can do in simple terms is just to get them, I can actually, okay, whenever you see such questions, always look for the key. The key is root 10. Now remember, we have root 10 being said that is what? Irrational. So now, how can I get root 10 from root 2 plus root 5? So what I can do is to multiply the entire equation by the root of what? 2. If I multiply the entire equation by the root of 2, root 2 times root 2, I'll get what? 2. Then root 2 times root 5, according to SAD formation, we know that if you have root a times root a, you basically get a. If you have root a times root b, you basically get the root of what? ab. Don't forget this important SAD form. So having this thought, it means that if I multiply root 2 by root 5, I'll get root what? 10, being equal to root 2 times a, that is root 2a over b. Now I want to reach a point where the left-hand side should not equal to the right-hand side, because if I've been told to prove that something is irrational, in the end, I have to make sure that it is irrational. You get the idea, okay? So it means that I can get this 2 and take it the other side and have root 10 being equal to root 2a over what? b. And when the 2 comes the other side, miraculously speaking, I don't even know why, it becomes what? Negative. So mathematically speaking, if you want, you can always show them that you are pro and you came from a wonderful high school. So you can get root 2a over b minus 2, then say over 1. Look for a common denominator. Be a big professional. So the common denominator will be b. Then we basically know a b into b, that's 1 times that. That will be root 2a. Then maintain the minus. Then 1 into b is b times 2. That will be like 2b. So basically you end up having root 10 being equal to the root of 2a minus 2b over b. Now the funny thing is this. In the first place, you assumed root 2 plus root 5 to be rational. And if it is rational, remember, something rational should be equal to the form of a over what? B. And if that's the case, what does that mean? It means that if I assume that statement, then root 2 plus root 5 should be written in the form of a over b, which means that whatever I have on this side should be equivalent to what I have on that side. But in this case, where I multiply by root 2 throughout, I ended up having root 10 being equal to some rational values. So it means that what I'm having here is rational, but what I'm having here, according to the statement I've been told, is irrational. Now, remember, tomatoes cannot equal to guavas. So according to that statement, I can also say rational cannot be equal to irrational. In fact, since it's root 10 being equal to irrational, so I can say irrational cannot be equal to rational. And as usual, we give a superhero statement by the method of contradiction. Method of contradiction. Remember, proving root 2 plus root 5 is also irrational. Just like that, once you solve, you can always walk out of the exam room or the test room timing as a guy. But anyway, let's move on to question number 3. We've been told to prove that 1 over root 2 is irrational, assuming that root 2 is also irrational. So here basically what we'll do is the same thing. Remember, give the statement. What method am I using? You say method of contradiction. So now with this method, I can assume the opposite. So now I will assume that 1 over root 2 is rational. But now I'm having 1 over root 2, and this does not look nice. So what am I going to do? I'm having 1 over root 2. So basically, there are so many ways you can actually solve this question. So many ways. But the easiest way is this. So if this is rational, it means that 1 over root 2 can be written in the form of a over b. One of the smartest tricks you can always do is by always trying to get what is in the statement. You've been told that assume that root 2 is irrational. So I want to get a statement where tomatoes cannot equal to guavas. So I want a statement where irrational cannot equal to what? Rational. So what I'm going to do is that I'm going to make at least one side of the equation to appear like the other side. Sorry, like the statement that I have in question, which is like root 2. So what I'm going to do is that I'm going to introduce a minus power to both sides of the equation, because whatever I do on one side should be done on the other. So I'll say minus 1, even this side, minus 1. So remember, whenever you raise a fraction to a minus power, it means that you have to reciprocate the inside, which means whatever is at the top will go at the bottom, top. As usual. So this means that you have root 2 over 1 being equal to, yes, what's the reciprocal here? It's going to be b over a. Now look at this. You're having root 2 being equal to b over a. Remember, this is what? Rational. But the other guy is not rational. So we can say that irrational cannot equal to what? Rational. Irrational cannot equal to rational, because we've been told in question that root 2 is irrational. And we know b over a is rational, because I can have a number such as b and another number a at the bottom. So I can give my superior statement. This is literally how you solve this, by saying by the method of contradiction. By the method of contradiction. What am I proving? Remember, 1 over root 2 is irrational. So that's how you go about solving this question. Once you go about solving in this manner, then you are safe. All right, now look at this other guy. It says, assuming that root 3 is an irrational number, prove that 1 plus root 3 is an irrational number. Okay, guys, I think you can try this on your own. You can always pause the video and attempt to do it on your own. That's if you want. But remember, we have some information. We're being told that root 2 is an irrational number. So I'm trying to prove that 1 plus root 3 is also irrational. So remember, give the method that you're using. So method of contradiction. All right, so with that method, what am I going to do? So I'll first assume that what I have to prove is the opposite. So assume that 1 plus root 3 is what? Rational. And if that's true, then it means 1 plus root 3 is equal to what? A over b. But I want to reach a statement where I would say tomatoes are not equal to guavas because I've already been told that something will actually make everything go wrong, which is the root 3. So I'll just take the 1 and take it the other side and have root 3 being equal to a over b minus 1. So remember, you can always get this, put it somewhere, say some data, and solve a over b minus 1 over 1. Common denominator, b. b into b, that's 1 times a, that's a. Maintain the sign, minus 1. 1 into b is b times 1, that's b. So I'm having root 3 being equal to a minus b over 1. Now, remember, I've been told that assume that root 3 is what? Irrational. So basically, I'll say, okay, irrational cannot be equal to what? Rational. Irrational cannot be equal to rational. Then, as usual, what do we do? Exactly, give the superior what? Statement by the method of contradiction. By the method of contradiction. What are we proving? 1 plus root 3 is an irrational number. Irrational number. Just like that. All right, let's look at the last question. Given that root 5 is not irrational, prove that that guy is also not irrational. So basically, whenever you see something like this in math, as you are proving, just try and destroy it. Just try and make something that will make sense. Okay, so given that root 5 is not irrational, is it supposed to be like this? Not exactly. It's supposed to be, this question was root of 2. There was a mistake in the question. Sorry about that. So given that root 2 is not irrational, prove that 1 over 1 plus root 2 is also not irrational. So basically, I'll first get this and deal with it. So 1 plus root 2. So whenever you see this, always rationalize the denominator. So by rationalizing, I'll multiply by what? The conjugate, which is the exact same thing, but in the case I'm having a plus, I put a minus root 2 over 1 minus root 2. Now remember, I'm having 1 in the denominator multiplying these guys, so 1 times anything will not change anything, so I'm having 1 minus root 2. Now for the bottom, these are conjugate pairs. So for conjugate pairs, the first number multiplies the first number. So 1 times 1, that's 1. Then the second number multiplies the second number. So root 2 times minus root 2, that would be like minus 2. And I have 1 minus root 2 over 1 minus root 2, that will give me like negative 1. Now negative 1 into 1, that's negative 1. Negative 1 into negative root 2, that is plus root 2. So basically, I'm proving this. You see, it even looks much better. It looks prettier, as you girls would like to term it. So you have minus root 1 plus root 2. So that's what we're proving. So we give the method, so method of contradiction. Contradiction. Okay, forgive my handwriting. Give it. Anyway, so let's assume the opposite. So assume what we're proving, which is minus 1 plus root 2 is rational. This means that minus 1 plus root 2 is equal to a over b. Now basically, you will reach a point where you say tomatoes cannot be equal to guavas. So I'll take the minus 1, take it the other side, and I'll have root 2 being equal to a over b, then plus 1. I'll say, okay, let me just say plus 1 for now. Plus 1 like that. Now, I can always do up a data, solve a over b plus 1 over 1. Common denominator is b. b into b, that's 1 times a, that's a. Yeah. Then maintain the sign, plus 1 into b is b times 1, that's b. So I'm having root 2 being equal to a plus b over b. Remember, I did make mention that this guy is equal to something rational. So regardless of what I'm having this side, remember this side is rational. So now root 2 in the statement is given that it's not rational. So now irrational, which is root 2, cannot be equal to rational, which is a plus b over b. And then what do we do? Give the superior statement by the method of contradiction. What are we proving? I can always use this statement that looks a bit complicated. 1 over 1 plus root 2 is also irrational. All right, so now this is how you go about solving this. Now, there are other pointers that I would want you to pay attention. Like, for instance, as you are proving, sometimes if you want, it's just that I'm skipping that point, but if you want, that is, if you just want to, like, solve everything clearly, when you reach this point where you assume that it's rational, and then you're saying that it can be written in the form of a over b, you can even give a statement as you are solving, because it's like analytic. So you can say, where a and b are maybe a member of, real numbers. Yeah, because real numbers are rational and irrational numbers. So you can give that statement. If you want, you can just say, where a comma b is a member of what? Real numbers. You can give all these statements if you want. This will also help you understand exactly as you are explaining. So don't forget. Yeah, that's how you go about solving this. Alright, thanks for watching. Remember, slow progress is better than no progress. If you have questions, you can reach me on WhatsApp on the number 077 149 5252. Remember to strategize before you become a statistic. And this one for that A+.